So let's go ahead and just kick this thing off. This is another remote digital RoMBIS session in the time of COVID. And what we're going to do today is we're going to have our guest, Brian Patty, who leads the, what do you want to call your, is it a design studio? What do you call VA Plus?
VA Plus is just our BIM consulting wing. So
BIM consulting. Okay.
Yeah, we're a part of Vertical Arts Inc. in total still. We assist them on projects as well, but for the most part, we are a BIM consulting team that either does BIM items for people or does BIM modeling embedded. So we've worked with a few local architects here in town and in the state of Colorado, as well as several international projects with like SOM and firms like that.
Okay, cool. So BIM consulting is the phrase that we're looking for your VA Plus arm.
Yep.
Great. Well, we're really happy to have you on, and we're excited to learn about the topic for today, which is, I guess, preparing schools to be able to open more safely in this time of COVID. If Carlo or Ian, if any of you have anything you want to chime in, please do. Otherwise, I'm going to go ahead and hand it over to Brian.
I'm good.
Okay. Well, let me see if I can get going here and if I can click on the correct things. And so just to start with, I ended up with this as we were talking before we got going here, Anthony. I have a second grader. My son's 7 and he attends University Prep, which is a DPS charter school over at Arapahoe in 24th. And just knowing how things had been prior to the pandemic, I used to go pick my son up in the after school program, so it was super easy. But the times I had to pick him up earlier, there's a lot of kids come out of an elementary school at once, and I'm like, holy cow, how are you going to do this during COVID? And I just asked them, and they were like, well, we're not quite sure yet. And at the same time, Autodesk, sends out a lot of flyers and webinars and things like that. And they sent out one that was particularly eye-catching to me about their InfraWorks mobility simulator, and showing how you could simulate people walking around in a building and kind of better understand how social distancing and things like that would work. And it kind of got the noodle rolling, and we'd already been working on a COVID social distancing tool anyway that we thought we could use like an entourage family in Revit and just do something pretty simple, quick and dirty. Well, quick and dirty turned out to be quite a bit longer and more involved as we got kind of into it and thinking about it. And as of today, we actually have the ability to have our app on the App Store, which I didn't know was as difficult or well vetted as it is, but they hammered around on us pretty good. And now you can go to the App Store, type in VA Plus, and you can actually go just get this here. And so I never knew that they did as much vetting as they did with this sort of stuff, but they do. This floor plan you're seeing in front of you now is actually my son's school in the campus that's at 24th and Arapahoe. They also have another one over on Steel Street. So there was 2 campuses we were able to work on here. And it looks like, pardon our chatting here, we've been trying to figure out where all our stuff is and make sure everything's ready to go. And let's see. Okay. So hopefully I can find this. We've been messing around with SharePoint. And let's see. That can't be the right one. Oh, shoot. My apologies here. I'm not finding the right file. We've got so many pieces that I don't want to show the wrong one to you guys. Looks like we've had some difficulty here. Let me jump to one of the other ones. This will get us going at least.
We are VA Plus, an innovative BIM consulting firm located in Denver, Colorado, with over 15 years of experience working on projects around the world to bring designers and clients' visions to fruition. Contact us today about our services, such as BIM modeling, BIM management, as-builts and conversions, scanning and point cloud services, custom solutions, and beyond. Learn more at vaplus.us. And thank you for watching.
Hi, my name is Brian Patty. I'm a parent of a second grader, Wesley, who currently is attending school online. I'm also a registered architect in the state of Colorado. Our firm, VA Plus, is the BIM consulting division of Vertical Arts, a Colorado design firm with offices in Denver, Steamboat Springs, and Edwards. We are currently assisting my son's elementary school, University Prep, as they make preparations for in-person instruction. We have spent several weeks developing tools and workflows centered around PDF floor plans, CAD files, BIM files, and mobility simulation software.
Our workflows are based on 4 key objectives: safer classrooms, safer circulation, safer arrivals and dismissals, and safer air. Safer classrooms. VA Plus is using Autodesk Revit generative design and our own workspace density planning tool to develop safer classroom layouts that accommodate social distancing guidelines. Safer circulation. By implementing one-way corridors and not crossing cohorts, the protective effects of social distancing measures can be enhanced. Safer arrivals and dismissals. Using classroom loads and safer circulation, we can simulate student flow and help schools evaluate the need and benefits of staggered arrival and departure plans, and provide a framework for staffing demand and logistical communication requirements for implementing these plans effectively. And safer air. We are looking for mechanical engineers that can use components of our workspace density planning tool to integrate airflow analysis data into Autodesk Revit. Revit is a CAD BIM software package that architects and engineers routinely use. Our tool can be used to represent students, so an engineer can analyze the airflow and aerosol transmission potential with current HVAC and classroom layouts, and what mitigation options are available.
All right, so let me back out of this one. One thing we ran across, let's see here, stop sharing for a second. One thing we ran across with what we looked at, Autodesk has a computational fluid dynamics program that they advertise with some of these pieces as far as even the mobility simulation. Mobility simulation is inside of InfraWorks and actually comes in the AEC collection. CFD does not, and is apparently extremely specialized and about $12,000. So not sure why they were pushing that particular part of it. So we haven't been able to run into any partners that have actually been able to do anything with the idea of the safer air and stuff. So right now we're, I think, looking at maybe a simpler approach, but still looking for, you know, an adequate partner to potentially help schools evaluate that. It's also, I don't know how much DPS and other schools are really doing with that, just because the expense of doing any upgrades or changing anything, or even just the uncertainty of, you know, throwing in air purifiers and other things like that. So it feels like information has kind of gone along all over the place. Anthony, I have one question for you. It looks like John is having trouble getting on, and he has the other video. Is there a way to allow him in?
He should be able to just join. It's an open Zoom.
Is there something I could send from here, maybe?
If you click on the participants list at the bottom, it's going to pop up kind of a list of the active participants, and then there's an invite button that you can click.
I see.
If you click on that, you could copy the invite link.
Okay.
And directly message that.
Yeah. All right, and let's see how many different ways we can communicate and see if we pass ourselves. Sorry about this, is having a little trouble getting things uploaded from where we're at here. Let's see. I think while he's doing that, let me go ahead and I've got another segment here that I can, I believe, go ahead and show. Let's see. Let's go ahead and, actually, am I sharing right now? Let's see.
No, you're not.
Okay. And go ahead and do that. And there we go.
My son's school, like many schools that you're going to run into, didn't have a BIM model for their campus or anything like that. They simply had some pretty rough PDFs on some pretty small scale paper. What we're going to cover in this process is just what it's like to take in a PDF and essentially set up the minimum amount to be able to evaluate it. First, we'll go ahead and just open up a blank file and go get the PDF by going to Insert. Pick out the PDF. I like to change the resolution a little higher based upon it being a small scale PDF, so the size shouldn't be a problem. Drop in a reference line in here to be able to establish the scale, and then just to position it here to confirm that you've got everything correct. Once you're happy with the scale, you can go ahead and lock this file down by pinning it. Just double check it here real quick. Make sure that, yeah, that matches up reasonably close to what we think is the right size. So from here, what we're going to do is we're going to go in and we're going to actually use room separation lines in rooms to draw out the minimum amount of information to allow us to do rooms. The reason to do rooms is it allows us to schedule per room and per level, and also per building. That way we can determine loads and understand the entire system. And also you saw in here that went ahead and just, I like to be able to see the rooms themselves. Just makes it more clear which ones I've actually gotten done. We'll move to another classroom here, and first thing we're going to do is you can see that we've just got a simple room tag. It's being driven by a comment to show how many students are in there, just to make it a little easier. Next, we'll go ahead and we'll just do a quick offset with some detail lines in the room, about 2 feet, just to imagine where students actually could get to. Then we'll go ahead and we'll start to we'll place the student in here, and then we'll go ahead and we'll array this student. And reasonably maybe get 4 in this row. Then let's go ahead, and what we'll do next is we'll go ahead and put in some circulation and make sure that we're spacing the students out correctly. And again, it's just using the inner circle as the person, in this case a teacher, so it's a little larger than the students since these are elementary school students, and then a 3-foot social distancing based on DPS's standards. And what we're doing here is we're just using some simple filtering on these views to make it easier to see the circulation versus the students. And we'll go ahead and add a couple more rows of students in here. Move them into place. So we've got achievable density in this layout, and establish that we've got enough circulation for the students to actually move around. And go ahead, in this particular classroom that'll have two teachers in it, and we can start to look at alternate ways of where we can put maybe some circulation for either the students to move around in, or enough room for teachers to actually have a desk and for some normal function as far as the chalkboard or whiteboard operations in the classroom. Next, you can kind of see what we've done with this is we went ahead and we set up a schedule to report what was going on in each one of the classrooms. And pretty simple parameters, just using a level, the room name, the description is something we use to filter, so we're only getting the students and not the teachers. and then went ahead and sorted it by level. That way we could get subtotals and you could get a good sense of what you had at each floor. Next, we went ahead and printed off the sheets with the floor plans into PDFs, brought them into Bluebeam where we marked them up and just indicated some loads as well as some one-way paths of travel. So to do the paths of travels, would simply just use a markup tool, the polyline, and had a arrow on one end just to indicate direction. So again, nothing too complicated here, but just allowed them to very easily see with some colorful visuals how it is that students would be able to circulate without mixing cohorts within the school. The dismissals were essentially a reversal of those same paths since the cohorts aren't supposed to mix with one another, and we kept the arrivals and dismissals from the same doors.
Okay. And Anthony, it looks like John is now in. If you could make him the presenter, and John, when you go to share your screen, make sure you click the two boxes that allow video and sound to be shared. Then you should be able to launch right after my piece.
All right.
And John, you should be a co-host now, so you're good to go.
Doesn't look like his camera or his mic is on.
There we go. We can see your screen now, John.
Our workflow utilizes the generative design tool in Revit to create new classroom layouts. For this classroom, we will be generating a layout of student desks using a modification of the workspace layout script that comes with Revit's generative design tool. This allows us to explore. Oh my God. Honestly, I'm going to start again. I had some issues with the playback on here where it seems like it's only showing one window at a time for some strange reason. I don't know. I'm figuring it out.
John, do you want me to show Adam's piece while you're figuring that out?
Yeah, go ahead and put that on. I don't know what's going on with this.
All right. Let me go ahead and do that, and I'll go find it. Sorry, folks, here we're having a little bit of technical difficulty.
Oh, no problem. I think, John, you might want to stop sharing your screen so that Brian can share his.
Yeah. Oh, there it is. Okay.
Awesome. Thank you.
All right. Anthony, can you see my screen okay?
We do not see a screen yet.
Okay, so
You might have jumped the gun right as John was stopping to share.
I gotcha. That sounds like something I'd do. All right, let's try that again. All right, you see my screen now?
We sure do.
All right, let's try to get this show back on the road here.
Mobility Simulator in Autodesk's InfraWorks was the perfect tool for us to use to validate our proposal. We were able to simulate our specific dismissal plan and see if it met our client's goals and COVID-19 guidelines. The tool has enabled our clients to really visualize the dismissal plan and promote a more informed conversation leading to the best solution path. Benefits of using Mobility Simulator include showing how long dismissal and arrival will take, showing the length of each student trip, showing if social distancing is being met, and representing the traffic density at the pickup zone. Using the dismissal plan PDF outline, a network is created in Mobility Simulator to simulate the dismissal sequence. Classrooms are represented by areas, as well as the bus stop and pedestrian pickup zones. This allows us to route students from all the classrooms to the bus stop, the pedestrian pickup zones, as well as to the vehicle pickup zone based on real data provided by the school district. Social distancing is simulated by increasing the space parameter for people to the social distancing radius, as well as by adjusting the capacity of walkways to their length divided by social distancing radius. We wanted to show the bus dismissal taking place before the rest of the student dismissal to reduce corridor load. So we set up some additional terms and demand profiles, allowing us to stagger the dismissal of groups of students. Many school layouts will lead to conditions where there are multiple routes which connect destinations. This can be helpful in simulating typical situations where people will make choices more randomly, but for our purposes, we want all of the students to follow their dedicated paths, helping avoid collisions. We utilized the route spreading tool to eliminate deviation from the main paths. This tool is also used to test the network and make sure routes are connected and functioning as planned. We wanted to use the simulation to show the potential impact our plan would have on the vehicle queue for pickup, so we incorporated the vehicle pickup into our simulation. We have a group of cars assigned to fill up the pickup lot over the simulation time. As students arrive at the pickup lot, they will get into a waiting car and leave. We increased the time for students to get in the car to help simulate additional time the cars will be waiting in the parking stalls. To evaluate the simulation, we utilized the information shown in the Analysis tab, which gives a summary of trips with times and distances. We then reviewed the walking reports, which show individual trip times and distances, and the level of service, which shows if spacing is being met on all walkways. These tools can show that the client's goals are being met and their concerns addressed regarding the time for dismissal and the ability to enforce social distancing. Mobility Simulator can be used to solve a range of problems related to getting students safely back to school, from arrival sequences and class transition sequences to simulations for middle and high schools, as well as parking and class transition simulations at universities.
all right, John, have you been able to get your piece back up and running? I don't know if he's with us or not. Hey, Adam, you had another piece, right, that's a little bit more detailed with the mobility simulation. Is that also on our SharePoint site?
Yes, that one's just in the same folder you were looking in.
Okay, the basic. All right. So since I'm not hearing from John, I'm assuming he's still having some technical difficulties. So, what's that, John?
Oh, you hear me now?
No, that connection is terrible. I can barely hear you. I'm going to go ahead and run Adam's piece here, the basics. So this is a little bit more about how to actually use it versus what it can do.
Hi, my name is Adam Johnson, and I'm a BIM specialist at VA+. Today I'm going to show you some basic tools, workflows, and techniques to help you get started using Autodesk's Mobility Simulator. Autodesk Mobility Simulator is part of Autodesk's InfraWorks and is included with the AEC package. Wanting to learn more about this powerful software that our company already has access to, I spent just under 2 weeks working with Mobility Simulator to learn how it works and to explore how it could be used to improve architects' workflows and help them better solve their clients' problems. After learning the basics of the software, I began to explore how Mobility Simulator could be used to evaluate back-to-school procedures and help improve students and students' families' safety as schools are beginning to reopen during the COVID-19 pandemic. To get started, we are going to launch Autodesk InfraWorks to begin using Mobility Simulator. Open an InfraWorks project. It can be any project. Once we are in Mobility Simulator, we will start a new file anyway. And once we are in the model, we need to draw a traffic study area. Go to the Analyze tab, click on the Transportation drop-down, and then Mobility Simulator. This will then prompt you to draw a traffic study area by defining the corners of a polygon. Once you've drawn your shape, hit Enter, and then right-click within the area and select Mobility Simulator. This will launch the mobility simulation software. Please note that you will need to have a Java runtime environment or a JRE installed on your machine in order for this program to function. Once the software is open, go to File, New, and select Cancel when the wizard opens. This is our interface for Mobility Simulator. You can orbit with the left mouse button, pan with the right, and zoom in and out using the scroll wheel. Before we do any modeling, we need to make sure that we are in orthographic mode by hitting the O key. We also need to turn on some layers so that we see everything we need to as we are modeling. In the Layers tab, ensure that Walk Center Lines, Walk Connections, Handle End, and Handle Other are highlighted. Finally, select the top of the view cube to orient to a planned view. Now that our interface is set up, we are going to create a simple simulation in which we have pedestrians walking from an origin to a destination. Zoom in until the cursor length is about 50 feet. Right-click, click Walkway, and select New Walkway at Cursor. A window will open where you can input the length, width, as well as the name of your walkway. You will notice that the default length is set to the length of the cursor. We will make our walkway 6 feet wide and select OK. I'm going to add another leg to the walkway at an angle. If you deselect the walkway, you can rotate the view using the right mouse button. Then we will position the cursor just above our existing walkway and create a new walkway at the cursor again. Our simulation will need at least 2 walkways to function correctly. Another way to achieve this is by selecting your walkway with the middle mouse button, right-clicking, clicking Walkway, and selecting Bisect. This will divide your walkway up into 2 pieces connected by a walkway connection. Next, we are going to select the endpoints of our walkway, right-click, Walkways, New Connection to join them together. Next, we need to add areas. These are where people will originate from, as well as where they will travel to. To place an area, pan your model until the cursor is just above a walkway endpoint. Right-click, New Area at Cursor. It is critical that your area is connected to the walkway. You know they are connected if the walkway highlights when the area is selected. Also, if you select the walkway, it will indicate which area it is a part of. Do the same to place an area at the other end of your walkway. Save your model after creating your areas. This will force the program to correctly recognize the areas. With our network in place, we are going to move on to setting up the parameters and the demands for our simulation. First, we are going to set up the term for our simulation. Go to Parameters, Terms, and this will open up the Simulation Term window. Currently, this is set to run from 8 o'clock to 9 o'clock. Let us adjust this time to be from 8 to 8:30. Now we are going to add some person types. Go to Parameters, Person Types. Click on the plus button to add a person type. Then we can adjust their name, the color of their avatar, and some additional parameters. In the other tabs of this window, we can adjust other aspects of the person type, including their speed and other physical attributes. We can also create groupings of person types as well. Let us create another person type with a different color. Now say there are 80% of the first person type and 20% of the second. To show this in our simulation, go to Demand, Demand Divisions, and then input the percentages for Division 1. This means that demand created from Division 1 will include the input ratio of person types. Now that our parameters are set up, we are going to set up our demand. This is what will inform the simulation how many people are moving between the origins and destinations. Go to Demand and then Demands. This will open the demand editor. Click on the green plus button to add a new demand matrix. Ensure that Division 1 is selected and hit OK. This creates a matrix with all of our areas represented at each axis, one being origins, the other destinations. When you click on a box in the matrix, an arrow will appear in your model which shows the origins and destination as well as the direction of the trip you have selected. Let us add 200 people moving from one area to the next. Now that our demand is set up and trips have been generated, we are ready to begin the simulation. In the Simulation tab at the right of your screen, click on the green plus icon. This will create a new simulation with our current parameters and demands active. With the new simulation selected, click on the light bulb icon. This will make this the active simulation. Click on the play button to begin the simulation. You will now see your agents begin to complete their trips. Mobility simulation has many additional features that will allow you to simulate multimodal transit, pedestrian crossings, parking times, elevators, and much more complex networks to simulate real-world problems. Hopefully, this demonstration has provided a footing for you to get started using Mobility Simulator and help bring the power of this AEC included tool to your clients.
Okay. I think at this point, John, are you now ready?
Yeah.
All right. I've stopped sharing, so I think you can go ahead and select sharing and make sure those two pieces are clicked, and let's see the rest of this.
You're still sharing, Brian.
I am still. Oh, okay.
Oh, no, you weren't. Never mind. I'm sorry.
Utilizes the generative design tool in Revit. Our workflow utilizes the generative design tool in Revit to create new classroom layouts. For this classroom, we will be generating a layout of student desks using a modification of the workspace layout script that comes with Revit's generative design tool. This allows us to explore configurations and find the upper limit of how many student desks can exist in the room while complying with social distancing guidelines. We have modified the generative design script to also place our workspace family in addition to station furniture. These workspace families are a representation of an occupancy point, which is common across our workflow and allows for both generative and manual placement to have identically accessible, machine-readable results that are managed and reportable through our workspace density planning tool add-in, which also makes this data available for tools outside of Revit in the form of plain text files. In this project's case, the guidelines specify a radius of 3 feet for students and 6 feet for instructors. The social radius and inner human radius of workspace families can be adjusted in the family type, and multiple types can be used to represent different kinds of occupant stations, or to represent circulation nodes. Next, we generate layouts in the Revit Generative Design tool. Then select a desirable layout, and Generative Design places our workspace families in the model. A 6-foot radius workspace type is also manually placed to represent the occupancy point for the instructor. But in order to represent the higher mobility of this role, which must have access to the student workspaces, we will also place circulation nodes, which can be created as a type in the same workspace family by enabling the circulation parameter. This can signal to other tools, such as the Workspace Density Planning tool, other add-ins, or Dynamo scripts, that the instances of this type are to be evaluated as a passage with revolving occupancy which does not count towards occupancy totals of a room. Circulation nodes are placed in the aisles created by the Generative Design scripts layout, and we run the Workspace Density Planning tool to create a report. This process is performed for all the classrooms at the school. The passing workspace family instances will inform the final occupant counts for each classroom that are used downstream in InfraWorks mobility simulation in order to create a mobility study.
John, is that all that you have, or did you have an additional video?
That's all I've got.
Okay. Well, Anthony, and I guess all the RoMBIS participants here, kind of a lot of things we threw over, maybe not as organized as we were hoping to be, but anybody have any questions or anything about what they've seen?
Well, gosh, I have one right off the bat. Just, you know, it's really intriguing to me how it seems like you've taken multiple design tools to accomplish multiple design analysis solutions, right? Like seeing you in Bluebeam and InfraWorks and Revit and, you know, leveraging the generative design tool. I love seeing that you're taking all of these different approaches, but how did that come together? Like, you know, what was the background of landing on, we're going to try InfraWorks, we're going to try this tool, whatever that looked like?
Sure. Well, I mean, we were, gosh, I want to say back in maybe May, kicking around the idea of a COVID workplace, you know, density planning tool, trying to just envision how anybody would sort of open up an office. And we batted around some ideas about what we thought, and you saw kind of where I started. I'm the older fart in the group, if you will, and so I did the simple stuff and said, can we make a tool that's smart enough to do this, or helps reinforce kind of what I'm thinking in my own mind as a designer needs to be done. And we started there, and we didn't really have the school connection with it. We thought maybe office buildings and things like that might be the first targets. And then as, you know, the whole thing with schools kind of, you know, kept evolving, and there was some talk of in-person, but schedules kind of kept shifting. Again, as a parent, was like, well, this is going to impact me. And, you know, I have some skills, and especially luckily I'm surrounded by people with even better skills with John and Adam here, that we could, you know, maybe take a crack at helping them figure something out. And like I said, it just happened to coincide that I happened to bother to watch one of those, you know, ad videos from Autodesk. A guy named Julian in this territory was essentially hucking their wares, and had this quick little video showing InfraWorks and the mobility simulation as a part of it. And we kind of went, and I just went back and forth with them a little bit via email. Then we had a couple meetings, and it was clear that what they had showed us was possible, but the instructions and everything like that were pretty lean. And we just kind of kept pounding them until we ended up running into a couple other people at Autodesk. One of them was Edmundo Fernanda, I think. I can't remember his last name. I'd have to look it up. But he actually walked us through like a whole training, because there's just not much documentation on it. And Adam, like he says in the video, hammered at this thing for well over 2 weeks to try to really get it to do what we wanted, and went with a couple different meetings with them saying, hey, this part doesn't work, or where's the documentation of this and that. And they came through with filling in the gaps. And then Adam and John have just kind of kept developing their tools based upon problems I keep throwing at them, like, hey, can we do this? Can we do that? And so that's kind of how we work as a team with a lot of these things, just everybody bringing their own specialty to this, their own perspective. And we just didn't see tons and tons of things out there. I mean, there's so much software out there, right? And even the stuff that we all pay for, it's hard to know what's in that package. It feels like some days. But yeah, just a little bit of advertising and some communication and really digging in kind of got us there. And we've been, like I said, experimenting with this with my son's school and been trying to find ways to get out to the public to potentially get other designers, involved to help out their own schools. Because, what I hope, I mean, my son in a couple of weeks, maybe going back to the school, and with the limited cohorts and everything like that, hopefully they've thought through some stuff so that when there is some outbreaks and whatever else may happen, or if they can avoid them, great, but that we lessen the severity of this and make it safer. And, with multi-generational families and everything else like that, maybe we save somebody's family member or something like that, through this. So it was a way to get ourselves out there and also do some good.
So how did you, I'm also really curious about the connection to the school. How did you first maybe reach out to them? And then what was the process like of communicating with them, getting information that you could, all of that? That just really fascinates me too.
It's as difficult as you probably imagine based on that, asking that question. A few things. One, I'm a founding family member of the school, so my stepson went to kindergarten here as well. So I've known about the school since 2011. And so that helped. That got me over the hump of a few things, obviously. But it was just, I took the opportunity because I was going over there one day to pick up supplies. They've been real supportive of my son and all the other students of kicking out supplies, Chromebooks, things like that. And so you have to go occasionally as a parent and go pick things up. And I just took the opportunity to engage somebody. And one of the operational people there was handing it out. I was like, hey, Mike, how do I help with this? Are you guys thought through this? What's it going to be like? It feels nightmarish from my standpoint with no information about trying to pick my son up, assuming everything else is going okay. Can I help? And we've got, and I basically repeated the ad I'd seen from Autodesk. We have this and this, even though we were still figuring it out. Like, we'll do this pro bono because we need some time to get ourselves trained and make it work. But at the same time, you guys probably need some help. And they got me in contact with their chief operating officer, and we had a couple meetings, walk through some of their requirements and what they were thinking, and just did a couple meetings. And I think last week we did a meeting on Thursday with a parent teacher administrative group and walked them through where we were at. And now we've got we're going to be doing another meeting with them now that they have numbers. We've had a bunch of surveys go out asking, are you going in person? Are you doing, online? And so now they know their numbers, because I think in all DPS school cases, they're going to need some people to remain online simply to be able to keep cohort sizes within the guidelines, within the spaces and the staffing that they have to teach that way. So that's our next step.
I know my, not to get derailed on the specific logistics, but I know my brother is a teacher. He's a high school teacher up in Vermont, and they're going to an A/B system where the school body is broken up 50-50, and then they go in, half the school goes in Monday, Wednesday, the other half on Tuesday, Thursday, and then all remote Friday, and then repeat the cycle. And that was one way they're reducing the physical presence in a single day.
Yeah, I think they've all got to come up with fairly creative ways to reduce student population on campus at any particular time. And there's different sort of guidelines and thoughts around ages of children. I mean, it feels like, I don't know about you, but every day if I read stuff about this, there's different understanding or supposed understandings of how much transfer is there, what mechanisms are really active, who doesn't, things like that. And so it's definitely a moving target, but at least being able to provide a simple enough framework. And that's probably the other thing when you ask about, like, how do we end up with all these, sort of desperate tools to do this? Basically, it was how simple can we make each one of the solution paths such that we get actionable information based upon it. And that was, we think we have something. And again, we really right now have had, only impact at my son's school. So like I said, we're hoping to get this in front of others that may be able to help, with decision-making processes that I assume are going on right now.
Do you
If I
think?
can add,
Oh,
sorry.
go ahead.
If I can add a little bit to the idea behind the actionable items thing, the planning tool that we built we decided to go with a workspace-oriented approach as opposed to a heat map, which is what a lot of other tools that are out there are doing, because the workspace approach doesn't make assumptions based on precisions that we don't have access to. So we're trying to keep the data that it's working with focused on an actionable item throughout the whole process. So that is actually a deeper part of the design behind our process. But anyway, sorry.
That's a good point.
Real quick, I have a question. So I saw the teacher walkway, and it seemed to be a manual process. Have you guys thought of how to integrate that with the generative automated process, or did I just miss that part?
John, you want to go ahead and address that?
Yes. So actually, we did have some experiments where we actually didn't use the generative design tool to determine pathing, just because it's there's different approaches to it. It was a lot faster to do that in C# actually, and we did work with that for a little bit experimentally in terms of trying to determine if we could just generate circulation paths based on what the generative design tool had laid down in the model. We ultimately didn't go with it because we needed to have we needed a level of refinement for that to make it practical that wasn't worth it at the moment. So we just went with a human guided approach to circulation paths. That would be more, I guess, it would have been like a 2.0 kind of thing. And we needed to get the fundamentals down first.
Got it. Yeah, I was just kind of reflecting on that paired with the changing guidelines comment you made, Brian, and how if that could be in the 2.0 version, right? If that could be integrated, then it would be easier, I think, to adjust to those requirements without manually repathing walkways, for example. Like if they say 4 feet is the new radius for 6 to 9 year olds, still 3 feet for so-and-so, you could have a little more opportunity to use that iterative approach to find optimal solutions. But
I think you're right.
I totally get it.
Yeah, we definitely were struggling though to make sure that we could actually get rubber on the road kind of thing and beat the DPS deadline to get some useful information that they could act on. But I think so. That tool is fairly new, and we've not done tons with generative design, somewhat because of our relationship to our clients isn't really often oriented around that phase of design. We're often a lot more, as you see, kind of DD, CD sort of practical production refinement. And so our tools and our perspective tend to be kind of warped that way a little bit. So we've moved into the generative design tools a little bit slower simply because our needs are not as focused on that. But I think it is coming, and this being able to understand how it works and also just help clients through it is something that we're looking to gain more expertise on.
Yeah, I think as a refined solution, it's awesome. It's like Anthony was saying, it's taking a bunch of simple tools and putting them together in a meaningful way. So I think you guys have done a great job making it like usable, like getting a usable thing that people can get value from. So I wasn't criticizing, just thinking through.
A good point.
So that kind of leads to a question of what, and this might be hard to separate out between the actual development of the workflow and the tools, but what kind of effort would it take? Let's say this presentation resonated and another school contacted you and they're like, hey, we want to go through the same thing and we want to reevaluate how we're opening. How much effort would that take on your team to produce a solution? How much time,
Well, I kind of think it depends upon what the team is. I mean, obviously, my vision of this is if we were most successful, it would be designers would be reaching out to us to implement this tool with, partners and clients that they already have relationships with, to kind of be able to do the same thing like what you and I were talking about earlier, like how did you get this ball rolling, who did you contact, things like that, because that takes some time, and somebody with knowledge of the inside workings of that would be a preferred method. And then I think it's a matter of, again, what does the designer team know, and what do they need help with? That would probably be the ideal scenario. If we're drawn into it and doing it, I mean, getting even just a simple PDF and just laying out, classrooms. Obviously, the one we're looking at was, 2 cohorts per grade. So I want to say that they thought their numbers were somewhere around 300 or less of actual students that they would be evaluating. I think that took like an afternoon to do my simple layout, saying, what do you think about these circulation paths? Here's the loads, here are the arrival and dismissal, points of interest. Does this start to pass muster? Does this feel like you've been staffed? Does this meet your needs from that standpoint? And then if there was any refinement, taking John's tool and being able to maybe really evaluate classroom layouts, that might take a little bit more time, but another half day to a day potentially. And then depending upon how complex it is, Adam's role with the mobility simulation and how complicated they may want their drop-off, pickup, or bus systems, or whatever they're doing, that's the one that could probably take longer depending upon how complex their scenario is. Elementary schools, just by luck, turned out to be probably the easiest one to take on because they're the most controlled, least amount of moving parts most of the day. You look at like universities or high schools, and you've got a lot more complex system. And I think that's where you're seeing like what your brother's saying. They're going to something where they're having things or doing big swings and stuff to have a chance, just because of how much variable is going on there.
Right. No, that's really interesting. Thank you. So I guess we're getting close to the hour. Does anybody have any other questions or things they want to ask?
This is David. Oh, go ahead.
I was gonna say I gotta hop off for another meeting, but thank you, John and Brian, for your presentation, and Anthony for putting us, getting it going. I'll leave now.
Thanks for stopping by.
Carlo.
All right, see ya.
So this is David Goldwasser. One thing I'm wondering, this would be really useful or need. They can't really do that without the operational understanding of how the school is going to function. So I think that's really a good question. And I know for now, everyone's just trying to make the first step, but there'll be a time when they keep increasing students and then you have to redevelop the mobility analysis, unless it just happens over summer, right? Maybe we never get to full school this year, and then by the start of next year, there's not the staging. It might just, but that's optimistic. I would assume there'd be some type of staging where it gets more and more complete to in person, and then you have to reevaluate the mobility.
Yeah, I imagine each school is going to have their own thought process as to how it is they take the next step. And like I said, I think all we're doing is hopefully empowering designers and those teams and relationships to potentially look at it with a better informed perspective. And we'll see kind of, I guess, where the guidelines go and who wants to take this on, right? And see what the next stages are like. Hopefully we keep progressing in the right direction, and it's more, like you say, more complex, harder, and there's more people. But I guess we'll see.
So this isn't a question, but just a comment I was going to make. I put in a link to a NIST tool. They developed this for the same reason, where they had kids in school and they wanted to help. And so this is a single room modeling tool that's based on this CONTAM, which is a simpler, it's a pressure network versus, so air is mixed well within a zone. It's not a full CFD. And then CU has a similar web-based tool that's an Excel spreadsheet that tries to model something similar. So there's a few other local resources of,
Okay.
professionals who've tried to come up with ways to help analyze.
Yeah, I see the one link in here is if you could send me both links. David, are you somebody that we could maybe get in contact with to help understand how to use that a little bit more, and maybe pass that information on to school?
Sure, or have contacts with both CU and NIST. I work at the National Renewable Energy Lab. My background's architecture, but I work on software development for buildings. And so for Department of Energy, we're also looking at COVID-19, because we want to have an efficient building, but it has to be safe. And so there's that, not necessarily balancing, because you're not balancing safety versus efficiency. You need safety comes first. But, as COVID-19 ends, we need to look at how do we keep them safe, or can shift into kind of, pandemic mode, but then have the building operate efficiently other times.
Do those tools that you're mentioning have an API or some other way to do interoperability with? In other words, be able to
I know Contam, Contam does. So they built a web interface for this particular thing, but you can access it through an API.
Okay.
For that, and the Excel one, the CU one is just a spreadsheet that you can download, and so you can use that. Or actually, it works on Google Drive. I say so. It's not Excel. It's a Google Drive, Google spreadsheet.
All right.
I'll try to add a link to that here, or I can email it out after the meeting if I can't find it quick enough.
Yeah, David, I think if we have a chance to kind of look through that, if you're up for it, we'd love to just, maybe talk offline with you at some point, just to see if we understand maybe how we could take better advantage of this. Because I do believe, from what I've read anyway, and again, I'm an architect and not an engineer, that this is something that we feel a little blind to still, as far as its impact on design and what schools, if they can afford to do anything, what it is they're doing, and if they can't, what should we be worried about, and what changes our layouts based upon that.
Yeah, right. In schools that have the right climate, opening the windows is the best, easiest thing to do, right? But then it gets challenging in winter or in hot, humid climates. Yeah.
Yeah, since it's already snowed here once. Okay, well, that's great.
Yeah, I enjoyed this though. It was great seeing it. I was a little bit familiar with AnyLogic, which seems to have some similarities to this capability of they do discrete modeling of anything, but sometimes some people use it for buildings and people, but some people use it for manufacturing workflows.
Yeah, there's no end to the output of creative people. It seems like as we kept going along, are we even on the right path? Are we staying relevant? How will people use this? And I think the biggest challenge we found, though, is just a matter of connecting with people to see if we can affect change over a broader reach of people. Okay. Well, Anthony, are we about done here, you think?
I think so, but hey, this was really, really fascinating to learn about this. And I think I speak for all of us in saying we all appreciate that you're exploring this and trying to come up with ways to make the reopening process better. So what I'll say is thank you for the presentation. We at RoMBIS will kind of process the video. We'll make sure it goes up onto the YouTube channel. And I'll send out a message to everybody on the meetup site, just letting you know where that link is. You can share the link if you want to, and we'll have that recording for anybody else that was not able to attend.
Awesome. And we'll probably be posting a refined version of this. We have another webinar with Autodesk coming up in October, and I've still been kind of trying to track down AIA. We've had some back and forth to see if we can find our way on the calendar in any time frame that's relevant. And we're just, again, kind of keep searching for ways to connect the dots and see if we can help some more schools, at least in our region, if not beyond.
Yeah, no, that sounds great. And when you get those things kind of locked in with AIA and with the webinar, feel free, please share them on the Slack channel, and we can keep following what you're up to.
Will do. And if anybody else comes up with anything, or if we started any ideas loose, feel free to reach out to us. This is something we all have an interest in. I think getting the economy going and keeping people safe is in everybody's interest. So yeah, if you've got an idea or something, feel free to reach out.
Awesome.
Good.
We'll do that.
All right. Have a good afternoon, guys.
Bye, everyone.
Thank you, everyone. Bye.